Okay, hi guys. I was bored again, so this is the second part of the first unit, which is piecewise functions. So first of all, what is a piecewise function? Well, a piecewise function is a function that changes based on what the input of the function x is. So if I have f of x right here, right? Normally with a normal function, we just take x and we perform some operation on it, and that's it, right? With a piecewise function, what we're going to do is say, okay, well, what is x? Is x in one of some number of certain domains? In this case, it's 3, but it can be really any number. And then depending on which domain it is in, we're going to use different formulas on the actual x to get the function. So finding values of piecewise function. To find values of a piecewise function, we need to check to see which domain the x falls in, right? And then perform the relevant operations on the x to get the function. But, and this is an important thing to note, if the x doesn't fall into any of the domains, then f of x value is DNA, which means does not exist because there's no function to operate on, right? So if we have, for example, let's take f of -1. So let's go through each of our domains. Is -1 less than -6? No, it is not. So we're not going to use this one. Is -1 between -6 and 2? It is. So we're going to use this function, x plus 7. -1 plus 7 is 6. So f of -1 is equal to 6. Let's do one more. Let's say f of negative, no, not negative. Let's say f of 5, right? Is 5 less than -6? No. Is 5 in between -6 and 2? No. Is 5 greater than 2? Yes. So we're going to use this function, 5, so negative x plus 5, well, it's going to be -5 plus 6, which is equal to 1. All right, there we go. All right, so practice. Let's calculate f of -2, f of 0, f of 1, f of 2, and f of 5 with this. So f of -2, let's go through each of the domains. Is -2 less than -1? Yes, it is. So that's just going to be 3. If I have just a number here, that just means it's always going to be equal to that. F of 0 is 0 less than -1? No. Is 0 in between -1 and 1? Yes, it is. So we're going to use this one. -2 times 0 plus 1, that's going to be 1. So f of 0 is equal to 1. F of 1 is 1 less than -1? No. Is 1 in between -1 and 1? Well, we're including 1 in this range, right? So it is. So we're going to use that. So -2 times 1 plus 1, which is going to be equal to, well, it's -2 plus 1, which is going to be -1. Okay. F of 2 is 2 less than -1? No. Is 2 in between -1 and 1? No. Is 2 greater than 2? No. So none of these work. So f of 2 is going to be DNE because it fits in none of the domains because we're not including in this last domain, we are not including 2 right here. Finally, f of 5. Is 5 less than -1? No. Is 5 in between -1 and 1? No. Is 5 greater than or equal to 2? Is 5 greater than 2? Yes. So that's just going to be, function's going to be x, so f of 5 is equal to 5. Okay, graphing piecewise functions. To graph a piecewise function, just graph each function, but just in the domain given. So if I have like something that's like x minus 3 in, for x is less than 7, right? I'm still just going to graph that part of the function, x minus 3, but just only in this range. And then whatever the rest of it is, I'll graph those functions, but only in those ranges. The main important thing here is you got to make sure you're using the right dots for bounds. So if we have the end of a part of the piecewise function, right, an open dot means it's included. So an open dot is going to be with less than or greater than sign, and a closed dot, a filled in dot, means that that bound is included. So that's going to be less than or equal to or greater than or equal to. All right, practice. Graph the following equation. Let's see. So when x is less than -1, it's going to be 3. So that's going to be here. And that's going to -1. It's not including -1. So we're going to be there. F of x, when it's between -1 and 1, it's going to be -2x plus 1. So -1 times that is going to be 2 plus 1, so 3. So we're going to stay here. And then the final part of that is going to be 1, -2 times 1 plus 1 is going to be equal to -1. So that's going to be right about here. And that is included. That is filled in. And so we're going to draw a line from these 2 points to connect them. And then what's our third bit? Our third bit is it more than 2? So we're going to have an open hole at 2, and it's going to be x. So that's going to be like this. All right. And let's double check that. Yeah. So you can see our graph is a bit poor because I'm drawing, but it's what's correct. All right. Bye.